Alright, so we spent last week talking about certain statistics like mean, median, mode, and range. And for a couple of days now, we're going to be talking about something called a box plot. And a box plot helps us see how the data is spread. It helps us see the shape of the data. It has all kinds of interesting information to pull from it. So we're going to learn how to analyze a box plot and construct a box plot. So let's quickly go over the answers to the do now before we get to that. So go ahead and turn to the next page, please. All right, just to go over the answers to the do now real quickly. I think the only thing tricky about this set of data was that figuring out what does that dot represent. And of course it's halfway between 7 and 8, so that's going to be a 7.5. These dots represent 8.5 because it's halfway between 8 and 9, and then we have a 10.5 here. So here's the list of data from this dot plot. There are 15 numbers. So I added these all up, divided by 15, and got 8.63. The median, again I have 7 on this side, 7 on this side is 8.5 in the middle. The mode, you can clearly see, is 8. And the range is 11 minus 5, and that's going to be 6. And then I ask, does this data contain an outlier? And visually, it kind of looks like this is pretty far away from the rest of this group, but numerically, 5 is not that far from 7.5. So there really isn't an outlier in this data, even though it kind of looks like there is, but 5 is not that far away from the rest of this data set. If I were way down maybe at 1, or if we had 1 up here like at 20-something, maybe that would be an outlier, but 5 probably would not be considered an outlier in this case. All right, so let's move forward and talk about box plots. All right, so we're going to take a look at an example box plot, and I want you to just take a look at some data and then look at the box plot and see if you can figure out anything about this box plot. But also any other observations that you want to make about this picture and about these numbers connected to that picture. Come up with a couple here. So pause the video and come up with some observations, and then check back and we'll see what you could have observed. So here are a couple of my observations. I noticed that this seems to have 4 sections to it. The lowest number of the data is at the bottom of the picture. The highest piece of data is at the highest part, the largest data number. This middle looks like it might be the median, although not quite. But I think that might be a mistake because our median is 32.5. It's halfway between 32 and 33. Looks like this is at 32, but I think it should be at 32.5. So yeah, just a couple of things. So, I mean, I think it's pretty clear that the bottom dot represents our smallest number. The top dot represents our highest number. Question are, what are these dots representing? And let me just ask you one question. If you look at this half of the data, and let me draw a line just to kind of separate that. What's the middle number of this half of the data? So we have 1, 2, 3, 4, 5, 6, 7 pieces. So we have 3 on one side, 3 on the other. The middle of that half is 39. And take a look at where that dot is. It's at 39. If you do the same thing to the lower half, we have 3 and 3, and then a 28 in the middle. And take a look at that. That's where this dot is at 28. So it looks like potentially this dot is the middle of the top half, and this dot is the middle of the bottom half. All All right, so let's define this officially. So go ahead and turn to the next page, please. All right, so this box plot, sometimes also called a box and whisker plot, is based on 5 important numbers from a set of data. So the first number is the lowest value, also called the minimum. That's the lowest value of the data set. The next number is something called the lower quartile. And just like we did in the last example, it's the median of the lower half. So we have the lower quartile is the second number. And this should say not Q3, but Q1. I'm sorry, yes, that should say Q1. Stands for quarter 1. And again, it's the middle of the lower half. So the middle number is the median. It's the middle of your data set, and you could also think of it as Q2. All right, so the middle number, median, Q2. This number is the middle of the top half, so we call it the upper quartile. We also refer to this as Q3, so it's the middle of the top half. We call it Q3. It's the upper quartile. And then the highest number, the word we use for that is the maximum. So there you have these 5 important numbers that you develop the box plot from. So here you can see in this box plot that represents this data, the lowest is 25. Okay, so again, that's going to be the minimum. I'm just going to abbreviate that as minimum. The next number, that middle of the lower half, is 28, because here's our median, and again, I'm going to circle the median up here, all right? And if you look at the, the lower half, that doesn't include that median, right? That's the middle of the lower half, so we're going to call that Q1. And then 32 is our median. So I'm going to write that in, see if I can fit that in the box. Not so well, but that's the median. Yeah, let me write that a little bit neater. That's kind of messy. Let's do that again. That's a little better. And then we have the upper half. So this is Q3, and then we have our max at the very top. All right, that is how we put together a box plot. And you can see how we call it a box plot because it has boxes. But the 2 middle sections between the Q1 and Q3, we draw a box. It's 2 boxes that are divided by where the median is. And then we just have 2 lines that go from Q3 to the max and Q1 to the min. So it's line, box, box, line. And they call it a box and whisker plot. In some cases, they call these the boxes, and they call these the whiskers. So you may hear that as well. All right, so let's see what we can do with these box plots. Let's go ahead and turn to the next page. So one of the most important characteristics of a box plot is that each section of the box plot, and there are 4 of them, represents 25% of the data, or 1/4 of the data. But we tend to talk about it in percentages. So what I'm saying is that this section represents 25% of the data. This box represents 25% of the data. This box represents 25% of the data. And this last section represents 25% of the data. And we're talking about actual pieces of data. the number of numbers. So, for example, let's say I had 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. The bottom whisker would represent this bottom 25%. The next box would represent this 25% of the data. The next box would be this 25% of the data, and that last line would be 25% of the data. So you can kind of think of the numbers from the data being represented by each of these sections, right? And so, again, a box plot would look, something like this for this data. Again, these are represented by, these lines represent potential data points, data numbers. So you can answer a lot of questions knowing that. So let's take a look at a couple of these questions. So the first one says, what percent of the data values are before the median? So we know this middle number is the median. We then add all the sections below that. So we have a 125 section, we have another 25 section. So that means that 50% is below the median. And that should make sense because we know the median divides our data in half, so 50% will be below and 50% will be above. All right, next question. What percent of the data values are after the median? Well, if 50% are below, then of course 50% will be above. What percent of data values are in the box? And they're talking both boxes between the Q1 and Q3, or between the lower quartile and the upper quartile. That's 2 boxes that we're talking about, so that's also going to be 50%. And then it asks, what percent of data values are after the upper quartile? Here's our upper quartile number. So there's only one section above that. So that's going to be 25% of our data. And then it asks, what do you think the word quartile means? And quartile sounds like quarter, doesn't it? So it means each section is 1/4 of our data, one quarter of our data. It just means dividing something into fourths. So I'm just going to say divides data into fourths. I'll say into 1/4. Something like that. All right, so let's do a little bit of analysis of these data plots. So go ahead and turn to the next page, please. All right, so I want you to answer these questions. This first one is based on this box plot. Note that we don't know all the data points that go into this box plot, and that's okay. Box plot doesn't tell us about individual data numbers, it just tells us about how they're kind of spread out. So I want you to use this box plot, knowing what you know about what each of these numbers represents. And I want you to answer these questions, and then you have a couple of multiple choice questions as well. So pause the video, answer these questions, and then come back and see how you did. All right, check out these answers. The median, of course, that's that middle number of the box plot, is 8. The minimum is 5. The maximum is 13. And then this is a common question. You have 125 total people that this box plot represents, and it asks between 7 and 10. Well, that's 2 sections, which is going to add up to 50%. So 50% of the people walked between 7 and 10. And how do I figure out 50% of something? Well, it's 1/2 also of 120. So that's 60 people. All right, number 2, it asks for the upper quartile. That's going to be this end of the box here, that piece, and that represents 51. And then I know I said this was multiple choice, but obviously it's true and false. So the highest student on the test, it says it's 100, but it's not. That end of that box plot is 91, so that's our maximum. The range is 82, so range is high minus low, max minus min. That is true. The median is 79. 79 is our upper quartile, not the median. The median is 64. And then half of the students score between 45 and 79. Well, between 45 and 79 is 2 sections, and 2 sections adds up to 50%, which is the same as 1/2. So that answer is true. All right, go ahead to the next page. We'll do a little bit more practice. All right, here's a couple more box plots for you to answer questions on. So go ahead and pause the video, work on questions 4 and 5, and then come back and check your answers. All right, let's take a look at these answers. So with this box plot, it says the range is 55. That's not correct because 55 minus 5 is 50. The median age is 30. Right, that's not indicated by anything on this box plot. The median age is 40. Well, there's that middle part of the 2 boxes, so of course that is correct. And then just to check, the upper quartile is 40. Well, that upper quartile, the end of that box, is 45, so that is not true. So the answer is C. For number 5, what is the age range of temperatures? Again, our high looks like to be 95, our low looks to be about 55, so high minus low is 40. Half of the temperatures recorded were between 70 and 85, so here's 70, here's 85. That's 2 sections taken up, and each section is 25%, so yes, that's a total of 50%, and 50% is the same as 1/2. Let me write that. 1/2 is 50%. And then for number 3, so this is telling us how many numbers are represented in this box plot. So it says how many days had a temperature between 50 and 70. Well, 70 is the end of our first quartile, so we know that this from here below is 25% of our data points. So 25% is the same as 1/4 of 12. Again, you need to know that 25% and 1/4 are equivalent. So I multiply 1/4 times 12. Multiply across, multiply bottom, and I get 12 divided by 4. And so it's 3, and I should write 3 days. So we know what that number represents. All right, so that's the basics of box plots. And just to remind you that they're based on 5 very important numbers: the minimum, the maximum, the median, and then the upper quartile and the lower quartile. So 5 important numbers that you care about for this data. All right, so let me know if you have any questions on any of this, and if you don't, you may start the homework.